we don't provide directly the operand in the instruction. For example, add 5. So this add 5 means put the accumulator plus 5. So add 5 to the accumulator and store in the accumulator. So we don't put the directly the operand, like for example here is 5 is the operand. We don't put the operand in this in the instruction because till the time of execution we might not know what is the operand could be. That is why we use variable, because in programming there comes some time, after some time we can know the operand, and after that we can execute this instruction. So initially we don't know the operand, so that is why we don't give the operand directly in some cases, but in some cases we can give the operand directly also, but most of the cases we don't do. So we give variable to the instruction, and those variable could be present in the memory or in the register, both in the both place. There is some advantages of using addressing modes. Number one advantage is to reduce the number of bits in the addressing field of the instruction. So we use this addressing mode to reduce the number of bits in the addressing field of the instruction. For example, if we had the memory of size like 1k into 16, it means we have 1024 locations and the size of each location is 16 bits, and address given to each field is 16 bits, and one address is given to each 16 bit. So if we draw the diagram it will look like this. We have 1024 locations from 0 to last is 102 3 and each location size is 16 bits, and we give each 16 bit one address. So we need 1023 addresses for this memory location. So if we want to use this memory address in the instruction, then we have to give 10 bits address in the instruction, because we have 1024 location, and 1024 means 2 to the power 10, so we need 10 bits to represent each field. So we need 10 bits in the instruction. So if the instruction is like this, we need 10 bits to represent each location, 10 bits. So what we are going to do, we are going to use some techniques so that the number of bits required in the instruction is less. We are going to decrease the instruction, the bits required in the instruction field is, we are going to decrease that. Let's say operand is being executed in the CPU and it is stored in the register, and assume that we have 16 registers. So in order to identify each registers we need 4 bits, because 16 means 2 to the power 4. So to identify each register we need 4 bits. So if we use register, then the number of bits required in the instruction field is reduced to 10 to 4. So earlier we need 10 bits. Now if we use register, we only need 4 bits in the instruction. So from the one advantage, we find that the number of bits we can decrease that way. But decreasing the number of bits in the instruction might not always be possible. But whenever this is possible, we can use this because the size of the program will decrease if we can decrease the size of its instruction. And the other advantage is we give the programmer facilities like pointer at number one is pointer. So what is pointer? We don't give directly the memory address, we just give some address, and after giving going to that address we get the actual address where the actual operand is present, and that address is called as a effective address. So we just learn one word that is called effective address. So what is the effective address? Effective address is the address where the actual operand is present. We have to calculate the effective address from the address given in the instruction. So the main important thing we should remember that the address which is given in the instruction is might not be the always the case that this is the effective address. With the address present in the instruction, we might need to sometimes find the address where the actual operand is present, and that address is called effective address. So sometime we have to calculate the effective address from the address given in the instruction. Let's see an example to understand the effective address. Let's say a instruction is like add 200. So this is the address 200, and in the memory this address 200 is present. Let's say this is the address location where this 200 is present, and in this 200 address location we had an address called 300. Okay, so with this 200 we see that at 200 we had 300, so we need to go to 300 location, and after going to 300 location we can find the operand. Let's say operand is 12.5. So this is the actual operand. So where the actual operand is present, and that address is called effective address. So here 300 is the effective address, not 200, because at 200 we have a address, and at which and in this address we got the effective address. So where the actual operand is present, that address is called effective address. So 300 is here effective address. And using this idea we implement the pointer. So the advantage of you we just we learn earlier that the advantage of using addressing mode is pointer, and this is the way using the effective address we can you implement the pointer. The other advantage of is indexing of data. So what is the indexing of data? Indexing in array we implement the indexing of data. In array we know that in array there is some location, and each location is pointed by an index like 0, 1, 2, and we using addressing mode we do the indexing of data, like that in that here we are going to present, we have the address of the first location. So let's say it is 200, and if we add 200, if 200 means the third location, then if we add 200 plus 1, the index, we will get the second location. That is how we do the indexing of data. And the other advantage is program relocation. Program relocation. So we put the program at different time and the different location, and we just change the base address of that program. We don't change the all those addresses of the program, we just change the base address of the program. We'll learn about those things later briefly.